Hi everyone, welcome to Civil Engineering Related e-learning. My name is Justice Tsahla. Our subject today is Building Science N3. So we are going to treat this question 7 here. As you see, our topic today is about the framework. So question 1, we are told that we need to redraw a fully labeled space diagram. This is our space diagram to a scale of 1 centimeter equals to 0.5. Then question 2, we are going to calculate the magnitude of the two reactions, the RL and the RR. And then the last question, we are going to we're going to draw the force diagram with the scale of 1 centimeter equals to 2 kilonewtons. So ladies and gentlemen, this is our space diagram. So we are going to redraw this space diagram up to scale. With the given scale of 1 centimeter equals to 0.5. And then before you redraw this space diagram, it's very much too important to know the unknown here. What is it that is missing from this space diagram? So if you can check, we are going to calculate the two reactions later, but then for us to calculate the two reactions, we need to have our span here. There is no span here between the two reactions, the distance between the two. So for us to get this span, we need to redraw this space diagram and measure the distance between the two reactions. So I'll show you how to redraw this space diagram up to scale. Ladies and gentlemen, this is my space diagram up to scale. So I will show you how to redraw this space diagram with the set square, and then we apply this scale of 1 centimeter equals to 0.5. So we are going to start with line AF, this line here, up to scale. So for us to redraw this space diagram, we start with this line AF, and then we are given the distance of 2. So for us to get this distance, we need to use the scale of 1 centimeter equals to 0.5. So on your ruler, where there is 1, you replace it with 0.5. And then where there is 2, it's 1. When there is 3, it's 1.5, 4. 0.5, 1, 1.5, 2. 0.5, 1, 1.5, 2. Then it's this 2. Then after you draw with this line and this line. So if you can check, for us to construct this line, we are going to use this angle 30 on our set square, because the angle here it's 30. This angle. Then you construct your line here, and then make sure that your ruler here it's straight. Then you construct this line FE here with the set square of 30. This angle here it's 30 degrees, the angle. Then after you draw this straight line here, you draw this line. Then we move from this corner, we draw this GH line with the angle of 60. This is our angle 60. So you draw your line here, then you draw this line. Then after you draw this line as well, this line HI, it's 60. This angle it's 60. So you construct your line HI. So now we are going to construct this line, this angle 30. This angle here it's 30. This one, it's 30 as well. Then you label your members B, G, H, I, C, J, D, E, F, A, B. And then after, it's your point loads, these 3 point loads. Then the last part is to calculate the 2 reactions. So before we calculate the 2 reactions, we need to identify or to get or to find our span here. So for us to find the span here, we need to measure this space diagram, because now it's up to scale. So now check. We are going to measure our span here. It's 1, 2, 3, 4, 4.5. Then if you can check our distance here, it's 4.7 from RL to RR. So the distance here is 4.7. 4.7, the distance. It's 4.7. Then now let's calculate our reactions. Let's start with our RL. Then we take the moments about the RR. It's RL times the distance, which is 4.7, equals to 10 times the remaining distance. It's 4.7 divided by 2, it's 4.35. So read 2.35. 2.35. Then it's 10 times 2.35. 10 times 2.35 plus the next force here, it's 5.1. Then, sorry man, it's 10 times this distance here. 10 times 2.35. 10 times 2.35, because this force is in the middle. 10 times 2.35, and then the next force, it's 6 times the whole distance, which is 4.7. 6 times 4.7 and 10 times 2.35. Then 10 times 2.35 is 23.5, and then 6 times 4.7, it's 28.2. You add the 2, it's 51.7, and then you divide it by the 4.7, and then our RL, it's 11 kilonewtons. Let's calculate our RR, and then we take the moments about the RL. Because we take the moments about the RL, and then you say 10 times the remaining distance, because this force is in the middle. The remaining distance is 2.35 to RL. Is 10 times 2.35. Is this one, 10 times 2.35 plus the next force is 5.1 times the distance to RL, which is 4.7. So now 5.1 times 4.7 equals to 23.97. 10 times 2.35 is 23.5. You add the 2, it's 47.47. And then you divide them by 4.7. Then your RR, it's 10.1. So now let's prove. Let's prove that upwards forces equals to the downwards forces. These are our downwards forces, and then this is our upwards forces. When you add these two, they must give you the total of these two. Let's check. 6 plus 10 plus 5.1. For the downwards forces, 6 times 10, 6 plus 10 plus 5.1 equals to 21.1. It's for downwards forces. So let's go to our upwards forces, the two reactions, RL and RR. When you add the two, they must give you the total of this. Let's check. Then 10 5.1 plus 11, it's RR plus RL, it's 21.1. Then correct. Then our downwards forces equals to the upwards forces. So we are done with question 1 and question 2. Then let's go to the next question. So we need to draw a force diagram to a scale of 1 centimeter equals to 2 kilonewtons. So now let's draw our force diagram up to scale of 1 centimeter equals to 2 kilonewtons. Let's move clockwise. We move from E to A. Before you go to your forces, you draw your vertical line here. You draw the vertical line, and then you put E. You put this E. We start from E, then put it anywhere. Let me put E here. This is our point E. Then check from E to A. There is a force here. From E to A, there is a force which is 11. Then you take this 11, you divide it by the scale of 2 kilonewtons. It's going to give you 5.5. Then if you can check, from E to A, there is a force. This force is going up. This is your E. And then from E to A, we move 5.5 from E to A. It's 5.5. Then you put your A here. Then I told you guys that we move clockwise direction. So from A to B, there is a force that is going down. Take note. From A to B, the force is going down, which is 6. And then you take this 6, you divide it by the scale of 2. Then it's gonna be 3. Our last point here, it's A. Then we move down by 3. Then you put your B. This is your B. Then from B to C, there is a force that is going down, which is 10. You say 10 divided by 2, it's 5. This is our last point. From B to C, it's 5 because we divided the 10 by 2. Then it's 5. You move, it's moving downwards, yeah. From B to C, then you put your C here. This is your C. Point C. It's 5. 5. Then from C to D, there is a force that it's acting, and then which is 5.5. You say 5.5 divided by 2. This 2. 5.1 divided by 2, it's 2.55. The force is going down. Don't forget. Remember, our last point was C. So from C to D, there is a force that is going down by 5.1. You say 5.1 divided by 2 is 2.55. Then you put your D here. This is your D. From D to E, it must give you this number. From D to E, it must give you this number. And then it's 10.1. From D to E, it's 10.1 divided by 2. 10.1 divided by 2, it's 5.5. From D to E. From D to E. This is your D. This is your E. The force is going up. This force is going up. Don't forget that we take this number, we divide it by 2. There is a force that is acting up here. So it's 2.55. It's D This is our E. D, this is our E. Then it's 5.55, not 2.55, sorry. 5.5, not 5.5, 5.5 from D to E. From D to E, it's 5.5 because the force is going up. Then after you go back to your space diagram, you check the horizontals. We do have the horizontal B, horizontal C, and the horizontal E. Horizontal C, horizontal B, and horizontal E. Then we construct them here. Then we call. So now I've already constructed our 3 lines here. Horizontal D, C, sorry, horizontal C, E, B. Horizontal E, C, B. Then let's start here. Let's construct our line AF on our force diagram. Line AF, it's vertical. Take note, the F is at E, and then the A is at F. Line AF on our space diagram, it's vertical, so we do have our A, and then the F is at E. So we put our F here. E and F shares a point. Because now we do have our F, let's construct line FG. Line FG, it's 60 degrees, line FG. And don't forget that your G is at horizontal B. So we move from F, we construct our FG, but our G is at horizontal B. Then from F, you construct your FG, you go, this is your line FG, you go up, we need our FG, you construct your FG, and then you put G here. This is your line FG, and then G is at horizontal B. FG, G is at horizontal B. Now let's construct GH, and GH is at horizontal E. GH, this is our line GH, and then H is at horizontal E with the angle of 60. From G, you move down with 60, and then your H is at horizontal E. You construct your GH, and H is at horizontal E. GH, H is at horizontal E with the angle of 60. Now let's construct HI, and then I is at horizontal C with the angle of 60. You construct line HI, and I is at line HI, I is at horizontal C. Then you put your I here. HI, I is at horizontal C. This is your I. So now let's construct line IJ, and J is at vertical D. IJ, J is at vertical D. Now we construct line IJ from I with the set square of the angle of 60. This is your line IJ. Then you put your J here, line IJ, and then J is at vertical D. JD, it's vertical. Let's prove it on the space diagram. JD, it's vertical. Then that was the our last point. Then let's wrap this overlapping horizontal lines. This is our complete force diagram. So now we are going to our last part. We are going to identify line BG, AF, HE, HI, IC, the all lines we are going to identify. This is our members, the magnitude of these members, and the natures. So I'll show you how to get them or how to find them. Let's start with our magnitudes. And then the first one is AF. Then you go to your force diagram, you measure line AF, and then you multiply it by these two, the given scale. Line AF, line AF is 5.5. AF is 5.5 by 2. 5.5 by 2, it's 11. It's 11 kilonewtons. Then let's move to BG. This is our line BG. So we are going to measure this line and multiply it by the scale, the given scale. This is our line BG. When we measure it, it's 1.4. And then 1.4 divided by 2, we multiply it by 2, it's 2.8. 2.8 kilonewtons. Then let's go to GH. This is our line GH. Our line GH, this line is 2.8, and then 2.8 by 2, it's 5.6. 5.6 kilonewtons. Let's move to HI. HI, we measure line HI, it's 2.8, again multiply by 2, it's 5.6 kilonewtons. So let's move to IC. IC, it's 1.4. 1.4 multiplied by the scale of 2, it's 2.8. IC 2.8. IC 2.8. So let's move to IJ. IJ, we measure IJ and we multiply by 2 the scale of 2. IJ, it's 2.8 multiplied by 2, it's 5.6. Let's move to JD. This is our line. JD. Line JD, it's 5.55. No line, yeah, it's 5.55. 5.5 by 2, it's 11. Let's move to EH. We measure EH, we multiplied it by the scale of 2. EH, this is line EH, is 2.7. 2.7 by 2. 2.7 by 2, it's 5.4. So let's move to EJ. EJ. Now E and J are at the same point, so we are unable to find the magnitude, so it's redundant. Redundant, you just write redundant. So the next one is EF, and EF it is at E and F are at the same point, so we are unable to find the magnitude. It's also redundant. EF redundant. The last one is FG. FG. Let's measure FG. FG it's 2.8. 2.8 by 2 it's 5.6. 5.6 kilonewtons. So let's move to the last part. The last part is the nature. So it's very much important. The nature is the strut or the tie. So it's very much important to know how the strut looks like and the tie looks like. This is our strut, this is our tie. So now I'm going to show you how to find the struts and the ties. So firstly, you need to single out this corner. This is this corner. Then I move clockwise direction. Then you move from B to G. You go to your force diagram and you check B to G is going to the left. This is our line. BG is going to the left because we only focus on this corner. Then you put this arrow here. Then you put the opposite. Then line BG, it's a strut. It's the same as this one. BG, it's a strut. BG, it's a strut. Then we move from G to F. G to F is going down. This is our line GF. Then you put the arrow here because it's going down, and then you put the opposite here. Then it's a tie. It's the same as this one. This is our GF. It's a tie. Then you go back to your corner from F to A. You check on your force diagram from F to A. From F to A, it's going up. From F to A, it's going up. Go back to your space diagram. You put this arrow here because it's going up, and then the opposite there. Then this line, it's a strut. Strut. Line AF, it's a strut. AF, it's a strut. Then we move to this corner. You single out this corner. Here is this one. Then don't forget that we moved clockwise direction. Let's move from C to I. You go to your CI. From C to I is going to the left. CI, it's a strut. Then from I to H. I to H is going up. I to H is going up. Then you put this arrow here. You always start at the top, and then you put opposite here. HI, it's a strut. HI, it's a strut. From H to G, you go to your force diagram. From H to G is going up. It's going up. HG is going up, and then you put the opposite down there. GHHG, it's a strut. Then we move from B to G. You go to your force diagram. From B to G is going to the left. From B to G, it's a strut. We already got it from the first corner. Then now you single out this corner here. The next corner is this one. This is our force that is going down. Then we move from D to, we always move clockwise direction. Don't forget, people, from D to G. Sorry, D to J, not D to G. D to J is going up. J to D, JD. JD, you put, because it's going up, you put this arrow there, and then you put the opposite down there. Then, okay, sorry, I forgot to tell you that JD is a strut. Then now, from J to I, J to I. J to I is going down. J to I. This is our line. JI is going down. You put this arrow here, and then the opposite here. Then JI, it's a tie. It's the same as this one. It's a tie. JI, it's a tie. JI, it's a tie. IJ. From I to C, I to C is going to the right. I to C is going to the right. We got it from our second corner. Then now we move to this corner. You single out this corner. So this corner here is this one. This is D, J, E, H. So let's move from E to H. From E to H on our force diagram is going to the left. Then this is our line. EH is going to the left. Then we focus on this corner. It's going to the left. And then you put opposite. It's going to the left. You put opposite. Then it's a tie. EH, it's a tie. EH, it's a tie. So guys, because the two EA, EJ, and EF are the redundant, we are unable to check or to find if it's a tie or a strut. So it's 0, it's 0. Now, ladies and gentlemen, we have come to the end of our lesson today. Thanks for your time. Don't forget to like and share. And then don't forget to subscribe to my YouTube channel, which is Justice Tsetla. The name of the channel is Justice Tsetla. To those who have questions, if you have any questions, don't hesitate to place your questions on the comment section. Thank you.